Hello, welcome everybody. This is our robotics class week 7. So I hope that you guys were able to complete the assignment. I did receive a lot of them, so I believe that the answer is yes. Last week we started with this topic called basic components of a robot. And we were looking at really when you're looking at the engineering and you're actually building a robot, what are all of the parts, right? What are all of the components that you need to be able to build a robot? You know, it's fun to talk about them and research them, but when it actually comes to making them, we have to really understand all of these different parts. And so last week, what we did is we started with an overview and we looked at a couple of the main components of a robot. We looked at the body and the frame, the control system, the manipulators, the drivetrain, and we looked at different examples, and everybody had this sheet that they filled in. It was super easy. And so just to review, so the body frame, it provides the structure of the robot, right? So when every robot needs some sort of a structure. And then the CPU, or the central processing unit, that is like the brain of the robot, right? The little computer that's in there. The drivetrain, we know, helps to move, give the robot mobility. And then we talked about what is the drivetrain of a humanoid robot? Well, it would be legs, right? So this week we're going to continue. So I'm going to open up this slide thing here, and we will continue to look. So there are subsystems here that we need to take a look at. So if you want to just grab your notes, you don't need to write everything word for word, guys, because you also have the video that you can always go back to and pause if you need to refer to anything. But you can just jot down some of the main points as we go through. So we're talking about the robotics design system. So this is a real system that roboticists and engineers use when they are designing a robot. And so if you can imagine, you know, we've looked into a lot of these videos now, and one of them was they showed you inside of Boston Dynamics, right up in Boston. And I mean, they have huge offices there where this is somebody's job. They sit in front of a computer all day and they go through the design system, and they have, you know, programs where it allows them to create virtual robots, sketches of them, and try to figure out what the systems, what are they going to use, what the subsystems and things, what is it going to look like. And so it's important for you guys to realize, that's why I want you to see the big picture here. And I don't want you to think that robots just come out of thin air and it's like magic. This is somebody's real job. They have to actually sit there and think about, what is the purpose of this robot? What do I want it to do? And how can I design something that actually will be able to do that, right? So there are 6 main subsystems in the robotics design system. So if you just want to quickly jot these down, you can just write down the names of the subsystems. You do not need to go and write the descriptions, because we're going to talk about each one of them in this lesson. So the first subsystem is the structure, right? So obviously we need some parts to make a structure. Then we have our motion subsystem. So this is consisting of our motors, our gears, our servos. These are all going to allow the robot to have motion, right? We need power. Cannot make that robot move without having some batteries or charger or some sort of energy source, right? Sensors are super important, right? Some sensors that we've looked at last year in our Lego robotic, what was it, the Mindstorms, they had an ultrasonic sensor, a gyro sensor, color sensor. There's so many sensors, okay? We're gonna just look at a few of them today, but there's like hundreds of them. Logic, right? So the brain of the robot might use a microcontroller, which is kind of like a small computer for us to be able to, if you're the programmer, the person that's going in, writing the code for the robot, then you'll be focusing on the logic subsystem. And then there's a control subsystem. So maybe a sort of a transmitter, a joystick, a remote control. Is it controlled wirelessly? We have to think about how in the world are we controlling this thing, right? When we turn it on. So these are all of our subsystems that we have to think about when we are designing a robot. Okay, so hopefully you just jotted those down because that is one of the questions in the homework tonight. Name the 6 subsystems in the robotics design system. So hopefully you can do that. All right, so let's take a look at the first, well, actually, before we do that, I just jotted them down here and I put a picture of the human body just to kind of get you guys to start thinking about how, as we're creating these robots, a lot of these systems, they can be related back to the human body. Like, for example, the structural subsystem, it's similar to the skeleton in the human body, right? That's what gives us our structure. The motion subsystem is similar to the muscles, right? Allowing us to move around. Our power subsystem, similar to the circulatory system, giving us our energy, right? And sending it all through our body. Our sensors are similar to our 5 senses that we have. And our logic is similar to our brain, right? To be able to give the robot the ability to think and have some sort of knowledge where it can make decisions based on its environment. So it is interesting to see how these systems really can relate and are similar to, they're trying to really create similar to how our human body has all of our different systems, right? And so when you're thinking about designing a robot, you'll have to think similarly, and how can I now create this type of a subsystem within this machine, right? Okay, so I put this little picture here because we're talking about structure. So robots, a lot of robots are made from different types of aluminum, steel, types of metal components like bolts, nuts, screws. So if you ever go and look at a robot up close, you'll see that a lot of these pieces, they make up the body frame, right? So these parts are the skeleton of the robot, and all of the other parts are attached to the skeleton in some way or form, right? So they are attached to this structural subsystem. And that's like our main, to get our robot, you know, to get it started, right? So so we start with that system. So like when we were making our Wigglebot, we had that red Solo cup. That was kind of like our structural subsystem, right? That gave us a body frame to work with, and everything, all the other parts were attached to it, right? So I'm just using the Wigglebot because if you're new here and it's your first year, all of the students in the previous years, they made this, their first robot was called the Wigglebot, and it was like a red Solo cup. And we had a DC motor to make it wiggle. And then we had a battery pack, and we added 3 markers. And so our little robot was able to draw with the markers because it wiggled around. So if you hear me talking about the Wigglebot, don't be sitting there thinking, oh man, this person, what is she talking about, a Wigglebot? I'm talking about the first robot that we made back a couple of years ago. So if you're new, sorry about that. If you want to make it, let me know. I can send you it's really simple. So if you're interested, it's your first year with robotics, let me know. Okay, so yeah, so we have to have some sort of a body frame, right? So hopefully that makes sense to you guys. All right, our motion subsystem. So it makes the robot move, right? It's the muscle of the robot. So the key component of the motion system here is something called an actuator. And this is something which causes a mechanical system to move. So we have to think about what that is, okay? And we're gonna look at that in the next slide. So motors and servos, these can all rotate and they can give motion to the robot. So I put this picture up because this first one here is our classic DC motor. And this is what, you know what, it's funny, I found one on the floor before. Oh, here it is. I'll show you guys. So this is our classic DC motor. This is what we used in our Wigglebot. So here it is. Look, voila, there it is, little DC motor. So this is what we used in our Wigglebot. And when we put it on the top of the red solo cup, and this was connected to the battery pack, it started to vibrate. And as it was creating the motion and it was on top of the cup, it was allowing the cup to move around, right? So it was giving it motion. So you can see it's a teeny tiny little motor. These motors are used in a lot of just starter robotics projects. They're really inexpensive. You can get them on Amazon. So if you're somebody who like loves to make things and tinker around, you can check out DC motors and you can come up with ideas of things, how you could use this in your motion, as your motion system in a robot that you might want to build at home. Okay, because I believe, I'm trying to still think ahead, but one of the projects I was thinking about for you guys this year is to have you design an actual robot. So go through each of these 6 subsystems and actually think about what would you use and how would you design your robot if you were actually really going to make it. So some other types you can see, there's a lot of different, there's a geared DC motor, there's hydraulics, right? So there's a lot of different types of actuators that can give motion to a robot. And they do get sophisticated and depending on the type of robot, right? So if you, again, if you're interested, this is just a very basic informational, class. As you go into high school, college, your career, it gets very in-depth studying robotics. And so if that's you and you really are interested in this topic, I would suggest you could go a little bit further and do some research, and you could learn more about these things because they can be fascinating for people who are really interested in this. Okay, the next subsystem is the power subsystem. So this is, of course, vital to the operation of all the electronic parts on the robot, right? Because you can have your robot and it looks so great and you're all ready with it. You have your structure, you have your motors, but then it's time to turn it on. And if you don't have a power source, nothing is going to happen, right? You're going to press the button, beep, and nothing's going to happen. So you have to think about how will you power your robot. So a lot of robots are powered with battery packs, rechargeable batteries, and they provide the energy to the robot. So again, I don't think I have a oh, I do. What do you know? Lucky day. Here is a battery pack. So this was the battery pack that we used for our Wigglebot. It uses AAA batteries. And we attached this to the top of the cup. And then what we did is we took the 2 little wires, the leads on the wires, you can see them. We connected them to our DC motor. And what do you think it did? Oh, actually, I could probably show you guys. I could show you on the video. So if I connect the wires here, so I have to connect them on. I don't know if this will work, but yeah, I don't know. It might be, this might be broken. But yeah, when I connect it on, it powers up the motor. So, but you guys probably remember from when we did the project. So again, we need some sort of an energy source. Okay, our sensor subsystem. Now there's so many sensors. So I'm not going to go through, of course, I'm just going to go through some of the ones that we've heard of and we've used before. So this obviously gives the robot the ability to detect various things in its environment. So it's the eyes and the ears of the robot, right? They can even enable a robot to function independently of human control. So I put this little picture, somebody looking through binoculars, I see you. And so our sense of sight, right? We want to be able to allow our robot to see, to actually hear, right? So again, you have to try and think, okay, there's so many sensors out there. Which sensors am I going to use? So I put a few on here. Do you remember? So we did, again, if you're new, I'm really sorry, but we used this program called Coder Z. Last year, we tried it out. It was a virtual robotics program. And what it was the Lego Mindstorm robot. and it was a virtual robot. And then what we did is we were able to code and control it in the virtual environment. And one of the sensors that this robot had was an ultrasonic sensor. And if you guys remember, what it did is it allowed us to measure the distance from the wall, right? Because we were always starting out somewhere and we had to go through all these mazes, and we needed to know how far was the robot from the wall so that we could figure out how far it needs to travel, right? Without hitting the wall, and then it can turn and go the other direction. But the ultrasonic sensor measures distance by using ultrasonic waves. So that's basically what it does. It uses these waves to help it gather the information and figure out what the distance is from whatever it is that where it's going. So obviously a sensor that can be used when we're moving our robot around. Our gyroscope, again, the gyroscopic sensor, that was another sensor that was inside of our Lego robot. And if you guys remember, this one was definitely tricky to figure out. It does require some math, but it measures motion, specifically angles, right? So when we needed to turn, if we needed to turn, like, for example, 45 degrees, 90 degrees, our gyroscopic sensor was able to help us figure out whatever the angle was, right? And so again, that can be helpful in when we need to move our robot around, right? So I just put a little picture of kind of what it looks like. Excuse me. Our light sensor. So this can be very helpful, because what if we want our robot to turn on when, I don't know, the light is off, or when the light is on? So it can detect the presence or absence of light, and then it can do whatever we tell it to do. So if we say, when the lights are off and it's dark, you turn off, then the light sensor will sense, oh, it's dark, turn off. And when the light is on, then you turn on, right? So that can be very helpful, again, for whatever we need our robot to do. Color sensors. So this is a type of sensor that emits light from a transmitter and then detects the light reflected back from the detection object with a receiver. So it's looking at whatever the detection object is, it's focusing on it, right? It's emitting this light, and then it's taking it back and receiving it back, and then whatever it's being able to be told, it can recognize the color. So it can recognize whatever color it is. So again, this can be helpful for our robot, depending on what it is that we're asking it to do. If we need it to be able to sense color, then we could use a color sensor, okay? An encoder. So again, you might remember this from the Lego robot. We had these things called rotary encoders, and they were inside of the tire, the wheel of the robot. And so this is a mechanical motion sensor. And if you remember, when we would get the reading back, it would be a digital reading, like a number would come up. And that would tell us how many times our motion sensor recorded the wheel going around and going around and going and making one full circle around. And that was able to help us calculate the distance traveled by the robot, right? So remember, again, it required some math, because we had to know the circumference of the actual wheel, which is the distance around the entire circle. Because if we were imagining taking our circle and flattening it out into a straight line, and maybe we said, okay, it made, 2 rotations, then we knew that the distance it traveled was however long that circumference was times 2, right? Because we knew, oh, okay, it made 2 full motions around. So again, it's a motion sensor, and it can help for us to know the distance traveled by our robot. So again, depending on not all robots use all of these sensors, because they have different purposes. They have different reasons, right? Reasons for robots are 4Ds. And so it really depends on the purpose and like why you would need the sensor for whatever the information is. Our logic subsystem. So the logic subsystem is the robot's brain, basically, right? So a microcontroller, most commonly used, it's a small computer. It stores the programming for the robot. So it could be like a little chip that goes into the robot, and whatever code you put into it is now what is being used to control and give the robot a brain, intelligence, right? One of our 4 needs for robots was intelligence. They need to have some sort of instruction on what they're doing, right? So again, that was your code. So how do you do this? Everything comes together, right? We're using all the sensors. The sensors are giving the robot the ability to collect information. Now it takes the information into its microcontroller, its computer. It processes it, and it figures out what to do with it, right? Because we're telling it different algorithms. What is an algorithm? It's giving it some sort of an instruction. For example, when you hit a wall, back up, turn around. It's like telling it, like we gave the example with the light and the dark. When your light sensor detects darkness, turn off. So all of this information we have to program into our little computer here. So that way, when then the robot's turned on and it's using all its sensors and taking in the information, it knows what to do with it, right? Because we gave it some sort of a brain to know what to do with it. So hopefully that makes sense. And then our last subsystem is our control subsystem. So it enables the human operator to maneuver the robot. So again, is it a joystick, right? This is a picture of a joystick. Is it some sort of like buttons, right? Like on a little screen. Is it wireless? Like, I don't know. It really depends, again, on the purpose of your robot. And then, you know, what meets your need for this particular robot. So they use a lot of different controls. And you'll notice that if the more you study robots, you'll see there's a lot of different controllers. I mean, I think back to that underwater mermaid robot that was like the deep sea one. And I know they were using 2 joysticks to control the hands. And they were able to really kind of feel what the robot was feeling, right? So again, it really depends on what your reason is, your purpose is for the actual robot. How will you control it, right? I don't know. It depends. So hopefully this helps to give you an overview of all of the subsystems of the robots. I'm going to just quickly pull up the sheet. So everybody's going to get one of these sheets. So this is our, see if I can make it a little bit bigger. So this is our review sheet that you guys will be working on. So it says components of a robot subsystems. You have to follow along and fill in the blanks. So it's everything that we literally just went through in this lesson, naming the 6 subsystems. Here, hang on one second, somebody. So sorry about that. So here's our review sheet. This will be your homework. Please type in the answers. I really would like everything to be typed out at this point because this is technology and robotics. So obviously I'm expecting you to use technology, and everybody knows how to use Google Docs and Microsoft Word. So if you could open this in Google Docs and just type the answers in, and then you could just share it with me. So name the 6 subsystems. And then I have a bunch of other review ones. So they're all literally straight from the lesson. If you took notes, or even if you go back and like pause the video or whatever, all of the answers are in there. And this is a good review for you guys because, like I said, when I end up giving a project on this, and I say, okay, we're going to be designing, you'll be coming up with a design, use the 6 subsystems. And then you're like, I have no idea what that is. So please keep a hold of these, the review sheets, okay? You can like keep them in your binder in the robotics section. All right, guys. So this will be due next week. And then if you have any questions, let me know. Otherwise, I will see you guys next time. All right, bye guys.